Now let us see about the analytic functions in this section. What is an analytic function? The analytic functions are the differentiable function of complex variables. Why we don't call this as just a differentiable function as in the case of a real function? It is indeed different from the differentiable real function for the following reason. If a function is differentiable, then in the real sense it will be differentiable at a point, but it need not be differentiable at the immediate neighboring point. Whereas in the case of an analytic function, if the function is differentiable or the function is differentiable at a point, then you will have the differentiability in a small neighborhood around that point also. For this reason only we call this as an analytic functions. So this is something unique for the complex variable function, which is not shared by the real valued functions. Now, in order to have the study of these functions, in this section I have included the basic complex number systems, its representations, modulus and amplitude form of the complex number, etc. And then the functions, and in the functions also we will have a characterization for a function to be analytic, which will be called as a Cauchy-Riemann's theorem. They are two different mathematicians. This will tell you when a given function is analytic or not. Okay, right. And also we will see certain properties of the analytic functions, which are, if f equal to u plus iv, then u and v are harmonic, and the function u equal to constant and v equal to constant. This will give you a family of curves, and those family of curves will be orthogonal to each other, okay, which one could see in the case of magnetism in physics, where you will have the electromotive field generated by two sets of curves which will be mutually orthogonal, and the EMF of that magnet or the magnetic field will be defined by an analytic function only. And we will be seeing about the harmonic conjugates of a function, and then how to construct an analytic function given the real part or the imaginary parts. And finally we will look into the transformations. The different transformations which we will be seeing in these sections are w equal to sin z, cos z, e to the power of z, and a general bilinear transformation az plus b by cz plus d. These transformations are a particular case of the complex analytic function, which will be called as a conformal mappings. The conformal mappings means the function which will preserve the angle between the curves. If you have two curves which intersect, and suppose if it is in a domain, and if you have a function, then you consider the image of these two curves, say gamma 1, gamma 2, and the image also will be defining two curves, and they will intersect, and what is the angle between them? If we have the case that the angle between the original is the same as the angle between their images, we call the function as a conformal mapping. And the transformations which I have enlisted are a particular case of the conformal mappings, which will have a wide ranging applications. These are the main things we will be seeing in this chapter.